The biggest parameter model ever that's open source came out recently. It's the Kimi K3 model. It has 2.8 trillion parameters, and what that means in specifics is that the 2.8 trillion weights and biases, which can consist of whatever the floating point precision is. Just say if it's a B float 16, then that means it has 16 bits or 16 ons and offs, or if it's in DRAM, it would be 16 16 transistors per parameter, which comes out to 16 times 2.8 trillion. So let's see, grab the calculator real quick and check it out. So calculator, 16 times 2.8 trillion. So that'll be, that's 2,000 million billion trillion. Say 1,000 million billion trillion. So 2.8 trillion, and multiply that by, already hits, multiply it by 16. So that comes out to about, or 4 with 13 zeros after it, or 4.48 with 11 zeros after it. So that's a lot. Okay, that would come out to, let's do the numbers on it real quick. Say each section of 3 numbers transitions from like 1,000 to 1,000,000 to 1,000,000,000 and so on. So there's 4 sets of 3 numbers in 13 and then 1 left over. So 1,000, million, billion, trillion. And so that would be roughly 45 trillion bits. So 45 trillion ons and offs in the computer for the new Kimi K3 model. And that is a pretty big model. So how big of a hard drive would it take to contain that? So divide that by 8 to convert it to bytes. That would be, say, 3, 6, 9, 12. So it's 1,000 million billion trillion. That's 5.6 terabytes hard drive to store the new Kimi K3 model. So the question I was wondering about is, do neural nets, maybe you can answer the question, I don't know the answer, how does transformers scale? Like, if something doubles in the number of parameters, does it roughly double the accuracy or the skill level or whatever metric you would use to measure how good a model is? If you know, let me know in the comments. Okay, now this is it says platform.kimi.ai. So this tells some stuff about it. I'm going to just go through here real quick. Okay, here's the comparison. Looks like, yeah. It says open frontier model size over time. Total parameters of each company's flagship model from July 2025 to July 2026. Sold equals released as of July 2026. Or solid, sorry. Dots equals frontier held, no new release since. It says right label equals company, something to do with the latest size. I don't know. Anyway, just on the graph, the y-axis is total parameters, and the x-axis is over time. So it appears that I think these are open source models it's comparing to. So previously, DeepSeek was 1.6 trillion parameters, and Kimi K3 is 2.8 trillion. So 16 times 2 is 32, so roughly almost double the size of the previous biggest model. And that's a big open source model. Okay, so now I'm going to scan through here and see if there's anything else interesting. Okay, here's something that's interesting too. I don't know if you can see it on here. I'll just go through it real fast. Looks like the input is here. Let's see, which way does this go? Oh, sorry. There's the embedding. So it's likely you input values or input text, and then it converts to vectors and the embedding vectors. Then it goes through probably the transformer block 1, 2, or transformer block 3, 2, 1. How is this structured? I don't know. Anyway, I'll just say some things on here. There's the transformer blocks, which consist of a attention layer, a multi-layer perceptron, and the normalization layers. Each one of those blocks likely consists of that if it's like a typical neural network. And then there's the KDA, I don't know what that is. The stable latent mixture of experts. I don't know what that is. I know what mixture of experts is, but not the other part. The gated MLA, the stable latent mixture of experts. There's linear norm. Let's see, there's linear. Those are linear layers, which is a typical single layer a single layer perceptron network, I guess we call it. A single hidden layer. And there's shared experts in the green color, and the purplish color are the routed experts, it says. And let's see, there's linear, norm, attention. Oh, this is an attention block, I suppose. Because remember I said it consists of a MLP, which in this case it may be a single layer perceptron instead of a multi-layer perceptron. There's adding, looks like it's adding possibly the residuals, and there's a normalization layer like I was talking about. There's the attention layer like I was talking about. This is a different type of attention layer, looks like. And it says it has convolutions in it, it looks like. So there's the linear, and it goes to convolutions, and then whatever that dot is or whatever. Then layer 2, and this one does this. I don't know what those green things represent. There's linear. Okay. So I guess that feeds to the attention layer. Then it gets normalized, partly so the numbers don't get too big. And then the residuals added to it appears. The reason residual connection is added is because it helps prevent vanishing gradients while training, and it can be more compute efficient as well during the, I believe it's, I think it affects the forward pass as well during inference. And let's see, or during training or inference. And then there's the linear layer. Okay. So, okay, that's pretty cool. Let's see if there's anything else interesting. Let's see, coding, knowledge work, getting started. Looks like it's pretty simple to implement, and it uses OpenAI's API for Python. It says basic call. Looks like it's pretty much like typical APIs for open source learned language models. Okay, let's see, vision. Oh, it can take vision input. For vision messages, content must be an array of objects, not a serialized string, so on. Oh, it can take video files too? Bro, that's cool. Wow. I think you would probably have to have the powerful computers to, 1, store it, and 2, to process all the computations. Let's see, structured output, partial mode, partial equals true. Okay. If you know what some of this stuff is that I didn't know about, let me know in the comments. Custom tools and tool choice. Apparently you can use tools with it as well, and so on. 1 million context and automatic caching. Wow, a context window of 1 million tokens. That's huge. That's more than any I've ever heard of. And important limits, etc. What is this? It K3 always has thinking mode enabled, it says. Max completion of tokens defaults to 130,000 about. Can be set up to 1 million. Okay, wow. So temperature, I guess that's default set to 1. And, okay, that's cool. Model processing, I guess, I don't know much about the Kimi model specifically, like if they host it or not. Like if you can rent or whatever the model from them, or if it'll work through other places like other places where you can get like Llama or get Llama 3 or Llama 4 or whatever, and so on. So, okay, that's pretty cool. And, all right, so, yeah, that's pretty interesting. A 2.8 trillion parameter artificial intelligence model. And that's huge. And from what I've seen, a little bit that I've researched, it can outperform, or it comes close to performing roughly like a lot of the previous versions of the frontier newest AI models, and maybe comes kind of close to some of the newest frontier models. So that's Kimi K3, and if you know any more about it, just let me know in the comments, and thanks for watching, and please click like and subscribe.